And welcome to Desk of Lady Ada, special
Late night.
Raspberry Pi new product edition.
Man, we are tired. It's 2 a.m., but we're here for it. It's been an exciting day here in America. I don't know if you knew, but today we inaugurated a new chip.
We did. It's it's RP2040.
It's the RP2040 day. What
Yeah.
a day to launch it. There's a new microcontroller on the block joining some of your favorites. And everybody's joining together, and we're going to make some cool hardware and some cool software for this chip. So let's get right in it. First off, everybody come on by. We'll answer questions live.
Yeah.
I'm sure we only have 3 people who are like, why are you
Well, there's
broadcasting?
people around the world. We do, every time there's a Pi launch, we're usually up early in the morning or late at night because of the time zone. So just real quick, what this is about. This is the new Raspberry Pi Pico.
Yes. So this is a kind of a 2 for launch. There's 2 things being released today. The Raspberry Pi Pico, and that's the board you see here, and then the chip on it is the RP2040, which is a new microcontroller chip. It's not quite available for sale yet, but they're sort of announcing both because this Pico is a dev board that showcases all the capabilities of the new RP2040, and it's available at a fantastic price, as little as $4 for just the bare board.
Yeah, we're going to show this
Very
off.
competitive.
We have, we're going to be showing the hardware.
Yeah, there's some hardware.
We've been working on Adafruit hardware with this chip as well. So
Yeah.
we have
Ding, ding.
Itsy Bitsies, we
Yeah.
have Feather, and then we have a bunch of other stuff we're working on. But let's kick it off.
Let's start straight with the RP2040. I am tired, but I wrote a bunch of text earlier today when I was awake and had some coffee.
Alright, so do you want me to go to your computer?
Yeah, why not? Let's go to the computer and we can go through the text. So first off, we have the RP2040 in the shop, but because of our system, we don't have it in stock. It'll be in stock tomorrow morning, like 7 a.m.
Yeah, just sign
like
up
in
now.
5 hours, okay?
Yeah, and the other thing is, if we only ship what we have in stock, so you'll probably see other people say they have these. If you can order it on our site, that means we have it.
We're totally going to have it.
If
Believe
we-
me, I physically saw them today.
Yeah.
But
if-
we're not going to activate it till the morning.
And if we are out of stock, just sign up. And one thing, you have a lot of choices when you purchase. So we don't harvest your email. You're not going to get signed up for newsletters. You're not going to get co-marketed to forever. Vote with your dollars with stuff like this. But if we have them in stock, you get them. So just sign up right now.
Yeah.
You'll get notified in the morning. But if you're seeing this and we have them in stock, that means they ship out instantly.
Well, for most people who are on a U.S. schedule, when they wake up in the morning and they see this, it'll be in stock. So so this is a new microcontroller board. It's about 2 inches long and approximately 0.8 inches wide, and it's got these castellated pads and these through holes. So if you're familiar with other microcontrollers, like Arduino Pro Minis or Feathers or Itsy Bitsies or whatnot, this is a familiar form factor. There's the USB connector on one end, a bunch of headers. You can plug it into a breadboard and wire up electronic circuitry, sensors, neopixels, OLEDs, displays, what have you. So there are a lot of GPIO, and Phil B made this gorgeous graphic, which you can download from the product page. So there are 40 pins on this board. Actually, can you hide me? Is that possible? Just so people can see the graphic.
Yeah.
Just like a temporary.
Yeah, keep going. I'll
Okay.
hide in a second.
So on the top right, there is the power system. So there's VBus and VSys. One is into USB and one is out of USB. Because this can be it acts as a USB peripheral, but it can also be a USB host. There's a 3-volt output. There's a little buck converter on here. I think it's probably the same one as on the Pi Zero. An enable pin. There's 3 analog inputs. That's the one thing you might want to think about when you are connecting hardware. There's not as many analog inputs as other microcontrollers you might be used to. It's pretty rare for us to see one that only has 3. Usually you get 6 to 12 or so. If you need a lot more analog inputs, we have I2C analog, breakout boards. So you could add more analog inputs, but just something to watch for. There's a reset pin, so you pull that low to reset the circuit. There's a lot of ground pins, so you see all these black ground markings. And then in between are all the GPIO. So this board has 25 GPIO. And that's not including, there's also an LED that's available. Okay, can you bring me back? Okay, cool. So the GPIO, so if you've used microcontrollers before, you're probably like, tell me about the peripherals. What do you got going on here? So I2C, there's two I2C peripherals, and every pin can be one of those I2C pins. So for example, pin GPIO 0 can be SDA, pin 1 can be SCL on the first I2C peripheral, and then GP2 and 3 can be SDA and SCL on the second. So they kind of like, you'll see it kind of alternates. You get like one of each option. So you can pick you can pick a variety of pins, but there's only two peripherals total. So it's not quite like a full crossbar like the NR52, but it's a lot more flexible than the SAMD 21 or 51, where you're like really fixed. Like every pin can only really be one thing, and you can't, it's tough to move the pins around. Two SPI ports. Actually, we'll talk a little bit about the peripherals in a second. So if you're like, oh, I need 3 I2Cs, or you need like 4 UARTs, just hold tight. Don't turn that dial. There's 2 SPI peripherals, and again, they alternate the pins. You can see like clock, data in, data out, chips, chip select. Although you can use any pin as a chip select if you don't want to use the peripheral chip select. And then etc. Every pin can be an SPI pin, but which one it is labeled on this diagram. There are 16 PWMs, and they come in pairs, and there are some duplicates. So, there's 16 PWMs, and each pin is a PWM, but there are a couple pins that have the same PWM output, so you can't use both of them as PWM at the same time. This is a pretty common thing if you've worked with other Cortex M0 chips. Okay, so now we've talked about the pins that you can use. So all these pins you can use for any kind of sensor connecting, or buttons or switches or LEDs. So let's talk about the chip itself. So the chip itself is a, let's see if I can get a zoom in pic. So this chip is a dual Cortex M0 running at about 125 megahertz. Why about? Well, documentation says it can be 133, but people tend to run at 125. It's about 125 megahertz. And you get 2 cores. So there's 2 microcontrollers inside. To make both run, different software requires some programming skill. By default, it's pretty easy just to run on a single core, which is plenty fast. But if you do want that dual core, that second core to do something for you, it's available. You can program it to also perform tasks. One of the neat things about this chip is it has oodles of RAM. So if you're used to stuff like the SAMD 21, another Cortex M0 chip, it has 32K of RAM. And even our biggest, baddest SAMD 51, the Grand Central, only has 256K. And this has 264K. Yes. So massive amount of RAM. Why does it have a massive amount of RAM? Well, let's go to the second point, and then you will understand the logic behind this. That's a microcontroller joke. It also has no built-in SPI flash or EEPROM. And that's unusual, because most microcontrollers have a built-in flash memory as little as 32K on an Atmega 328 using an Arduino Uno. Grand Central has up to 1 megabyte, or the NRF52 has 1 megabyte. You can get large flash memory. But this has 0 flash memory in it. In order to store your code, you need to have this external chip, this SPI flash, QSPI flash. Now, if you're used to Adafruit boards, this is really familiar to you. You're like, oh yeah, I've got CircuitPython boards, and they tend to have a little SPI flash chip that stores your code and also your files, fonts, images, audio files, whatever, graphics, whatever you want to store that your program uses as resources. So you'll always see a flash chip on every RP2040 board. So why did they design it this way? Well, this board's actually kind of interesting. It's actually kind of perfectly designed to run Python on hardware, because every Python on hardware board that we have, that's the Express series, that's really good at running CircuitPython or Micropython, needs a ton of RAM, because your code is running inside and loaded into RAM. So you need a lot more RAM than Arduino or C or C++ code needs. And you'll want that external SPI flash to hold your code.py, your text, and your resources, your files, your fonts, and your images. So what's neat about this is they got the price to be really low by kind of removing the things that CircuitPython and MicroPython don't need and optimizing the things that they do need, like a lot of RAM, but off-board SPI flash storage. It was kind of interesting. Another really cool thing about this chip is it has a built-in flash bootloader. So the button on here, the boot select button, if you hold that down while you power up the board, it'll go into a UF2 bootloader. Actually, you know what? Why don't I just show that off real fast and go to the computer. So here I've got my CircuitPy drive, but let me, let's go to my PC. I only hope that I don't like crash my computer or something. So if I hold down the boot cell button and I press reset, it shows up as another disk drive. And this disk drive is called Pi RP2. And if you open up the text, it says UF2 bootloader, Raspberry Pi RP2040. So this is a ROM bootloader. You cannot delete this bootloader. You cannot damage this bootloader. It is permanently in the chip, and it's a UF2 bootloader. Again, if you've used Adafruit products in the last couple of years, you know we love this bootloader because it's drag and drop. You drag and drop firmware onto it to quickly program it. There's also a USB command line interface. If you don't want to drag and drop, you can program the chip from like the command line or through automated tooling. But for beginners, this is great because there's no like DFU programmer or like JTAG, OCD, whatever. You just hold down the button while you plug it in and then drag a UF2 file over and it's loaded. So that's kind of nice too. Okay, so the next thing to chat about is, okay, so now we're going to get to the most interesting part of this chip. Save the best for last. So this chip doesn't have an I2S peripheral, right? And that's a little surprising. It also doesn't have like a parallel TFT driver or capture for camera. It's actually got only like the bare minimum peripherals. And especially I2S not being there is kind of weird. Like, why did they leave that off? Why have two I2Cs, two SPIs, two UARTs, but no I2S or other peripherals that are more complicated? And if you look at the datasheet, you'll notice that there's like, that's it, like that's kind of all you get. But instead, they have this state machine system called PIO. And PIO is interesting in that it allows you to create custom logic blocks, not quite like an FPGA, but it's the closest thing it can explain to. It's kind of like a CPLD or FPGA that's like really, really small. You can program it in assembler, and in MicroPython and CircuitPython, there's helpers to do that for you. And you can basically create a DMA engine that takes data in, and you give it a buffer of data, and then it does whatever you want with it. So, for example, a common thing that you want to do with microcontrollers is drive NeoPixels. And anyone who's ever had to write a NeoPixel driver knows it totally sucks to write one, because you have to have the clock timings for that one pin be like perfect, or you get like weird flickery effects. So for a lot of microcontrollers, what we do is we literally stop the microcontroller, turn off all interrupts, or like RTOS threads or whatever, bit bang the waveform for NeoPixels until we're completely done, which can take a couple milliseconds. And then we say, great, we can go back to work because we can't have any interruptions at all while we're writing that NeoPixel data. With PIO, that's not what you do. Instead, you create a little PIO block that says, I'm going to give you this data, and then you're going to shift one bit in at a time. And when it's a 1, the output pin is wide, and when it's a 0, you do this other square wave thing, and it's a couple of instructions. And then you just let it go. And it does it on its own. You can wait for it, or you don't have to wait for it. And then when it's done, it like sets a little flag, and you know, okay, my PIO computation engine is completed. So it can do things like NeoPixels is a great example because it's something familiar, but it can also do TFT displays, like toggling the read-write and DC bits for you. It can do LED matrices, so those Matrix Portal Hub 75 LED matrices. That's really trivial to do in PIO because it's all just like shifting some data out and then like toggling the latch pin. That's what it's perfect for. I2S or PDM, or like any other protocol where there's data being shifted in, and then you want pins to move on the other side, and you just need a little bit of logic and computation in the middle. So there's 8 PIO. I actually haven't played that much with PIO, so if you have questions about PIO, ask Scott, because he's an expert.
Scott is
He's in YouTube.
He's in the chats.
I think there's 2 engines, so you can have 2 separate PIO devices running, and each one of them has 4 state machines. So it's a total of like 8, but like it's like 2 runtimes each with like 4 accessible state machines that you can use. And the PIO code, the really cool PIO code that like can drive like a VGA display, at high speed and do I2S, that's all in the Pico C++ C SDK folder. Which brings us to our second point, which is kind of interesting. There is no Arduino Core for this at this time. So at the time of making this video, there's no Arduino.
So, we were all under, secrecy for this. So the blog post just went live on Arduino.
Oh yeah? What's the new?
Yeah, and so the blog post on Arduino,
what do they say?
They say, so they have a rendering of a board they're going to release. And then they say they're going to port the Arduino Core to this new architecture in order to enable everyone to use the RP2040 chip of the other Arduino ecosystem. Our team is already working on the porting effort. Stay tuned.
Okay, great.
So Arduino says they're doing it.
Yay! So one of the cool things is that the RP2040, not only did they get inspired by our UF2 bootloader, they're also using Teeny USB, which is the same USB core that we're using on our SAMD51, SAMD51 and NRF52 Arduino cores. So you'll get stuff like mass storage and like audio and keyboard and mouse, all that good stuff that you love. Teeny USB is like the official USB stack for the RP2040, which is a Synopsys IP stack, same as the one on the STM32. So it's good stuff. So Arduino's coming soon, but it's not available yet. Instead, you can either program it in C, C++, so you use, I think, the GCC compiler. There's makefiles. I'm sure Platform.io will be available like in 5.3 seconds for it. But you can just use a command line. Or you can use Micropython, which is kind of the expected way Raspberry Pi wants people to use it. They have a book, which I'll show shortly. Unless you have a photo. Oh, yeah, wait, can you show the book real fast?
Yeah.
I forgot I sent it to you. They have a book that's coming out that's like getting started with microcontrollers and Micropython. So that's probably released right now. I haven't been on the internet for 20 minutes because I've been doing this video. But you can download Micropython and install it on the Pico, or future hardware available with the RP2040. Or Scott has for the last month worked tirelessly to port the Pico and the RP2040 to CircuitPython.
And that means you get to do projects out of the box, drivers, accessories, everything. And that's also why we have a couple boards we'll talk about soon.
Okay, so you're probably like, great, I love the Pico. Pico, wonderful, amazing. But what about Feather? Now you're probably loving the Feather ecosystem. Lots of people make feathers, and we also made a feather. So this is our feather. I think this is like the perfect RP2040 board. I totally put like my heart and soul into this. So you've got USB-C, you've got battery charging, you've got a reset button and the bootloader select button. The Pico doesn't have a reset button, which was okay, but driving me a little crazy. Oh wait, go.
Sorry.
Yeah. It's got a Stemma QT connector at the end, so you can plug and play I2C devices. It's going to come with 4 megabytes of flash memory, keeps by flash. It's got all of the pins broken out where you expect them to be for Feather, so I2C, SPI, the 4 analog inputs. There's a NeoPixel, and the NeoPixel can also be turned off with a Gpio pin, so you can go into a low power mode if you want. There's an SWD debug port, optional. I don't think I'm going to pick and place it because it's a little bulky, but for those who want SWD, you can just solder in a connector, and now you can do debugging using your favorite SWD debugging port. Let's see what else we got. The charge LED and the pin 13 LED. So it's kind of like got everything. I got fit all together on this double-sided board. And one thing that we did for this board is the Gpio are the ones that are not I2C and SPI, the specialty labeled ones. All the Gpio are in a row on the GPIO. Sorry, let me look at this. Let me show the schematic because I have to. It's weird to explain this, but the pins, I put them in order. So even though they're labeled D4, D5, the GPIO itself, the underlying GPIO pins, are all sequential. And that's because the PIO really likes to only work with sequential pins. Like if you want to write 8 bits out of the PIO, they need to be in order. Like you can't easily write pins that are out of order or like on, it's all on one port, but you can't like write them in if they're in different locations. So I made sure that they're in sequential order. This and the Itsy Bitsy as well. So you can do kind of the hardcore PIO projects where you're like banging mass amounts of data. It's got USB-C, so people have been liking that. And then after we did that, we also designed an Itsy Bitsy. So let's look at that. The Itsy Bitsy is a little earlier in the design process. Like I forgot to put the silk screen on. But it's going to look like this. It's got the 2 buttons, still got QSPI, it's got a little dot star, micro USB because that's kind of standard. And also, this can act as a USB host. So, maybe people will use this as a USB host device. And I think I might go with castellated pads for this as well. But these are the kind of the 2 popular boards that we have in our family. I'm also experimenting a little bit with like maybe a Clue or maybe like a circuit playground. Those are still kind of in the design phase, a Cutie Pie maybe. But as soon as I get chips, I'll be definitely making the Feather and the Itsy. So those are the upcoming chips. How about we go to the overhead? And I can just show off this quick demo that I slapped together like 2 minutes beforehand. So this is just showing the Feather. I've got it with the stacking header so I can test stuff. And then what's really nice is it just works with all of our, I don't reset it by accident. It works with all of our sensors and libraries. So you can see the Blinka here in the corner. And I'm just having it print out the environmental data from this plug and play VME 680 sensor. And this just, a couple lines of CircuitPython code. And all the stuff that you've been using with our SAMD21, 51, and NRF boards works just fine. We even put a airlift feather wing connected to the internet. We plug this into the back of our display feather wings and like displayed animations.
Yeah, and just from like kind of my point of view of watching Arduino over the last decade, seeing what people were trying to do with projects, and then watching microcontrollers get sophisticated enough to run scripting languages, and then we saw Micropython, and then we decided let's make something really easy for beginners and just make everything just work with CircuitPython. I think what you're going to see is there's going to be a lot of people who want they like the idea of what Pico is, and they're going to want to use like all the accessories and libraries and sensors. So I think there are going to be people who are like, cool, this is like a $4 Pico board for Raspberry Pi. And then I think it's going to be, wow, I've heard about Feather, I know Feather, and they're going to want to build all the projects. Like we'll be able to pretty much have all of our projects just run with this new chip. Yeah,
we have I2C is working, SPI is working, NeoPixel's working. We're adding more PIO support, like trying to make it as fully featured as possible. I think UART's coming. Analog in works and digital out works, and I think PWM works as well. So we have all the basics working. The things that aren't working quite yet are I2S, because of course we have to implement it using this PIO system. Parallel displays, again, it's a PIO system thing, so we have to kind of rewrite that code specifically for this chip with that PIO system in mind, because we wouldn't be bit banging it. We would actually want to take advantage of this high speed state machine core. So I think this is kind of neat. I've been playing with this chip. It's really fast. I mean, it's Cortex M0, so it's a low price, but it's clocked so fast that you get close to SAMD51 type speeds. It is a perky chip thanks to the 120 megahertz clock rate and the ton of RAM, which is like really awesome. Even if you're executing off of QSPI flash, all that RAM means you can cache so many instructions that you're kind of executing from RAM, not from an external QSPI chip. Okay, so is there any questions?
Well, folks were, I would say if you put your questions in now, there was folks that were asking questions, and Scott got to most of them.
Well,
as
great.
as he was in there in the YouTube chat that is. Looks like there's a couple of folks from Pi Moroni. Hey, Pi Moroni. So also there's other partners. You should check out the blog post on raspberrypi.org.
Again, I have not seen the internet.
No. Well, everything wasn't, released until 2 a.m.
Yeah. Everyone's
it's fine. Pi Moroni has a cool board. They have this little gaming thing.
Mm-hmm.
SparkFun has a, they call it the thing, I think they call it a Thing M, but it's a feather. Looks like a feather.
It's like a long feather.
Yeah. And then they have an M2, and then we have Itsy Bitsy, and we have our feather, and then we have, obviously we're going to have other boards, Cutie Pie and Circuit Playground, stuff like that.
Yeah, and we're going to get chips hopefully the next month or so, and that'll let us get these into manufacture. So kick it off, but the Pico board, we have a CircuitPython build for it, ready to go. We're going to have a tutorial live shortly that I'm going to make live that we can, that folks can check out and get started with the Pico. But it's pretty much like all of our other CircuitPython boards. So if you've got existing CircuitPython code, you can sort of jump right in.
Yeah.
Okay, cool.
So if you go to our site, you'll be able to, we're putting these in stock in the morning, which is like 4 hours from now.
Yeah.
4 or 5 hours from now.
7 a.m. when the first shift comes in.
Yeah, so why don't you go to adafruit.com and show everybody where they're at on the site so they can start to...
Okay, cool. So if you go to adafruit.com/new, we've got the book. The book we haven't received yet, so when you if you sign up, it might be like a week or two. The Itsy Bitsy RP2040 and the Feather RP2040, we will manufacture as soon as we have chips. We don't have the chips yet. I think it'll be about a couple weeks, hopefully sooner. And then we have the Raspberry Pi Pico 2040, so that's just the bare board for $4. It'll be available in the morning. And the Pico RP2040 with some loose headers. So the board doesn't even come with headers, but if you want to use it in a breadboard, you probably want some. If you don't own any, that's no biggie. We have a version that just comes with extra headers for you, so you can quickly get soldered and plug into a breadboard for quick hacking around. So this is what it looks like in a half-size breadboard. Here's another image. So it's easy to solder. It just takes a few minutes. We have a tutorial on how to solder as well.
One person, this is an interesting analogy compared to, they're saying, so I guess this is a new 328p. Now, for those who are wondering what 328p is, that's back in like Arduino days from Atmel, which then turned to merged it with Microchip.
It is, it's in the same family. I don't ever like to say one chip completely replaces another. There's some reasons you might still want to use a 328. Like, for example, it runs at 5 volts, and this one's only at 3 volts. Now, this is much faster and much more powerful overall, but there's a lot of example code for the 328, so there might be situations where you want to use that chip. However, many projects that you would want to build with an Arduino or Arduino compatible, especially if Arduino is porting the code support over to this chip, you can just use this chip in its place. And it's like a near disposable price. Like, you don't have to worry about what if I break my project or my chip. It's like, just get another one. They're only $4.
All right. And let's see what else. If there's any questions here. RPI is pulling an apple. So the reason why someone's saying that is if you're making your own silicon nowadays, I think Raspberry Pi made a funny joke. They said all the fruit companies are making their own silicon.
Yeah.
So
this is the new M1.
Someone commented 3.3 volts should become the new universal. 5 volts is dying fast in new chips.
Yeah, it's very uncommon to, we make our boards compatible with both, but it is, no new chips are coming out that are 5 volts. It's
cool. Hackaday's article just went live. If you want to check out what's going on over there, you can check it out there.
Okay.
And I think that's going to be it. I think we're going to wrap this up. So go to our site. You can check out the boards. You can check out the Raspberry Pi site and more and see all the different boards. If you want, don't forget, sign up because these will be in the morning. So you can go to adafruit.com/pico.
Pick one up.
And pick one up. And you'll get
and we have plenty, so don't worry about it. We're not gonna run out.
Yeah,
in like 2 minutes.
We're gonna limit them to a certain number per customer, so if someone doesn't buy them all up and try to put them on eBay.
Yeah, they're not gonna. There's a lot of supply, way more. Believe me, way more supply than when the Pi 4 launches or the Pi 400. We got like 200 of those or something.
Yeah.
We got many thousands of these, so I'm not concerned about it. We're gonna have plenty in stock. So sleep in, even take a break, and when you're up.
All right, folks, we're looking forward to the Feather, and shout out to Scott for the work on CircuitPython on all this.
Yes, I think you order it tomorrow, you could get it by Friday or the weekend. We've got this guide we're going to publish tomorrow, and that'll get people started. I don't think anyone literally has these in hand unless you happen to be a reviewer. But it's super fun. I think this is good. I like disruption in industries, and this is a good disruption, right?
Yeah.
It's always nice when something comes out really powerful, really low cost. I like that there's competition, especially since for us as makers, as like a maker company, a chip that has so much RAM but is so inexpensive is a great showcase for CircuitPython.
And Scott's doing a deep dive on Friday about this, so check that out.
Okay. All right, rock on. So I totally forgot to make the guide live. I'm gonna make the guide live. We made.
All right.
And then we'll have a lot more tutorials and projects with this. I love Micropython, but I really recommend people try CircuitPython on these boards because the experience is really
it's cool.
Fun.
It's free to try both, but you know what isn't free? Your time. So if you want to do a project, figure out the project you want to do, and then look and see if there's code that's out there that's easy to use and documented and examples, and then do your project.
A lot of stuff just works, and it's like the magic of the shared API. Displays were working, Wi-Fi was working. Somebody was asking about one-wire temperature chips, and I was like, I don't know.
What's cool
I just connected it, and it just worked.
What's cool is when we were doing this behind the scenes, we started running our demos, and they just worked, and that's really cool.
NeoPixel stuff, all the animation.
That's what you want to do.
It just works.
Displays especially is really neat.
Okay, cool.
All right, that's it, everybody. Thanks so much.
Thanks, everybody. We'll be back. We'll, of course, be doing more Pico stuff, ask questions, post in our forums.
We're going to go to sleep for a few hours and wake right back up.
I'm really tired. So, yeah, I'm going to go to bed. Thanks, everybody.
Bye, folks.
Bye.
What is a microcontroller? A microcontroller is a small device used to control other parts of an electronic system that it is built into. If you've ever used an electric toothbrush, a keyboard, a television, or pretty much any electrical device, you'll have used something that has a microcontroller inside. Unlike general purpose computers, like Raspberry Pi or your laptop, microcontroller boards like your Raspberry Pi Pico don't necessarily come equipped with things like wireless internet, full-sized USB, or operating systems for everyday use. Instead, microcontrollers are much more pared-back devices, which typically use a combination of a processor, small amounts of memory, and some onboard peripherals to carry out instructions given to a larger system. They are usually much smaller and cheaper than a computer, and they usually use a lot less power. They are great for specific, defined tasks, whereas a computer can carry out a wide range of different tasks. To help you understand better, let's break down a Raspberry Pi Pico. Raspberry Pi Pico uses RP2040, a microcontroller chip designed by Raspberry Pi. This is the part of the board that does all the heavy lifting, and contains a processor and 264 kilobytes of memory, which, compared to most microcontrollers, is actually quite a large amount. This memory is important, as it executes the programs that are sent to it. All of the instructions, in the form of code, that you give your Pico will be processed in the chip, with the resulting output communicated to the electrical contacts, known as pins, on either side of the board. These pins are called Gpio, or General Purpose Input and Output. Connect header pins to these, and you can use them to easily control things like LED lights, buzzers, sensors, and displays. You'll find the pin numbers on the back of your board, but we've also supplied a diagram you can access and download online with all the pin numbers for you to reference. These bumps you see on the outside of the board are what are known as cancellations. These allow you to solder the board directly onto other circuit boards for more complex projects. You'll also notice 3 small pins at the bottom of your board. These are debug pins, used for finding errors in your programs. Starting off, you may not use these very often, but as you write bigger and more complex programs, they may prove useful. At the top, you'll find a micro USB connector. This is used to power your Pico via your computer or battery pack, and is also how you write programs onto your Pico from your computer. Simply connect a micro USB cable to your Pico and the other end to your computer. Finally, just below the USB port is a button marked boot cell. Holding this down while plugging your Pico into your computer will make it show up like a hard drive or memory card. Opening this will let you navigate to the Getting Started with Pico page by clicking on the index.html file. Now that we know what the parts of the board do, how do we actually get it to do things? Amongst other options, Raspberry Pi Pico supports Micropython, a beginner-friendly programming language based on Python. If you've ever used Python before, Micropython will seem pretty familiar. If you're just starting out, check out the book Get Started with Micropython on Raspberry Pi Pico from Raspberry Pi Press. To install Micropython on your Pico, you'll need to download what's called a UF2 file from the Getting Started page linked from the device. You'll find this under the Micropython tab. Then, once you've found your downloaded file, just drag and drop it onto your Pico. Your Pico will then reboot and will be ready for you to write your first program. You'll find out more about your Pico and everything you can do with it on the Getting Started page and at raspberrypi.org.